Hi, I'm Jeremy Hernan, and for my final year project, I have researched, designed and built 3 mobile robots and a user interface to teleoperate them. The 3 mobile robots were built to serve as a movable base for humanoid traffic control robots that can be controlled by a single user interface. Dr. Hamid Abdi, who is the supervisor of this project, has previously designed and built stationary humanoid traffic control robots that can be used to display messages to drivers and control traffic. The research and development done in this project will be vital in allowing traffic control robots to be teleoperated and driven under their own power. Each mobile robot will have to have at least 8 digital and 8 analog inputs and outputs to allow it to integrate with Dr. Abdi's humanoid robots and any sensors and actuators that are on it. As each robot is to be teleoperated, they must be fully wirelessly controlled and have a range of at least 25 meters. Each robot also has to have a live video feed that is displayed to the user interface so that the operator can see the robot's viewpoint and drive it without looking directly at it. Now that all the requirements of the project have been discovered, it is time to start designing and building the robots and interface. Initial research on how to meet all the requirements of the project found that the live video transmission would be the costliest and most involved part of the project. After researching multiple articles and similar robotics projects, it was found that a Raspberry Pi could easily be used as a web server that could stream live video and would be cheaper than using standard radio transmission video cameras such as those found on remote control cars. Raspberry Pi computers also have multiple digital input and output pins that can be used to control the needed digital inputs and outputs as well as the motors that drive the robots around. Drive systems were also researched to find the best way to move each robot around on the 2D plane. Differential steering was the steering option chosen as it allows the robots to move in 2 directions simply with the use of 2 motors without the need for any gearboxes or other steering systems. A prototype differential steering robot was made that was controlled by an Arduino microcontroller. In this video, the movement commands are sent wirelessly from a laptop over Bluetooth to the robots. The required components for this build were 2 motors, one for the left, one for the right, a motor driver to control them, a Raspberry Pi and a camera for the web server component and the live camera view, an Arduino microcontroller to control inputs and outputs, a battery to power it all, and a custom-built PCB that directs the power to each component as needed. There are also 8 LEDs and 8 switch inputs to prove that the digital inputs and outputs are functional. The chassis for each robot was designed in Autodesk Inventor with holes to suit all the components. Each chassis was then split into 4 pieces, which were 3D printed individually using PLA plastic and then superglued together. The components were then mounted to this chassis and wired together following the schematic. Each of the 3 robots were assembled in the same manner. Each robot runs a Python code on the Raspberry Pi when it boots up. This Python code launches a web server based off some HTML design. The user can then log into the server from any computer or phone on the local network and control the robots via the web server. The user interface also shows the viewpoint of all 3 robots at once, and an individual robot can be selected so that the user can control that robot. The Raspberry Pi directly controls the motor drivers via the GPO pins and sends messages over I2C protocols to the Arduino, which reads and writes the inputs and outputs. Currently, the LEDs on the robot show the outputs and switches are used as inputs. These robots and the user interface will provide a great adaptable base for Dr. Hamid's humanoid robots and could also be used for many other robotic applications which involve controlling many inputs and outputs or streaming video wirelessly.